Hey, fifth graders. All right, so we're going to do just a couple more of these. Really, lessons 4, 5, and 6 are all very, very closely related. So I figured that we might as well just do them, and that'll take you up to the checkpoint. I'm fairly confident. Yes, okay. So these are all about percents. Um, you guys all have some idea of what percent is because you ask me over and over again, what is the percent on the math test? If I got 95 out of 103, like what's that as a percentage? And I would figure it out for you. So we're going to be doing stuff like that. You're going to be converting, well, first of all, you're going to just kind of be doing like figuring out what the percentage is if you have a box that's shaded in, things like that. Then you're going to figure out what is the percentage based on decimal points. And then we're going to finish it off with what is percentage based off of fractions. So actually kind of a nice building blocks up there, because I think going from fractions to a percent is probably a little bit trickier than going from a decimal. In fact, it's much trickier than going from a decimal to a percent. Not sure how much I would really like the things being shaded in stuff, but it is what it is. Okay, now just because this involves a lot of shading, I am not going to draw a box up there, nor am I going to use my handy dandy thing. I'm going to trust you to look at your page and be able to kind of figure out what I'm talking about. So we're just going to jump right into number 1 here. Well, actually, one real quick thing. So with percents, benchmarks are still basically the same. So your benchmarks are going to be 25%, 50%, 75%, and 100%. Okay. So I don't know, just glancing at it, I see it as the math talk there in the lower right-hand corner on GR7. I think that it does come up at least once or twice in the once in the homework, and I don't know, looks like that's it. But just so you know, that whenever we're talking benchmarks, we're talking those sorts of things. If it asks you, what is this percentage close to, they're probably asking for benchmarks, so just do benchmarks, it's fine. I mean, I'm talking about percentage, you're like, what is 27 close to? Well, I guess it's close to 30, right? So it seems like you could do 30, but it's also close to 25, so it depends. Do you want benchmarks, or do you want just like simple rounding? They're not very clear in the book. Just do benchmarks, and then next year and in years after, just ask your teacher, hey, it says about, do you want benchmarks, or do you want me to just round it to the nearest whole number, or nearest 10% or whatever. So yeah, so let's talk number 1. So first of all, it says how many columns and single squares are shaded. So if you take a look at that, which is this thing right there, okay? And you count up all of the columns that are totally shaded, so up and down columns, and you count up all of those, there's 7 of them, okay? And then there's 4 more that are 4 squares that are also shaded. There are 100 total boxes, right? It's 10 columns and 10 in each column, or 10 rows and 10 in each row. So we have 74 squares out of 100. Okay? So 74 squares out of 100. Well, we would say that written as a percentage is 74%. Okay? So 74% means 74 out of 100 is what it is. So then it says what percent is unshaded. Well, we know that this is out of 100, right? So that means that all you have to do is go 100 minus 74, or you can just calculate it in your head. It's 26. You could have just added 1 more to this to make it 75, right? 75. How much is left over out of 100 if you take away 75 cents? Well, 25, but we didn't take away 75 cents. We took away 1 fewer cents, so there's 26 left over. So 74% are shaded. 26%, that's just terrible percent drawing. is unshaded. All right, pretty straightforward. Number 4 and 5, they ask you to shade in something that shows 20% or 86%. So basically, you're just going to shade in 20 squares, do them as either columns or rows, doesn't really matter which you choose, but just shade them in. Yeah, keep them together is what I'm trying to say. Don't shade 20 random squares throughout it, because then it'll look like the stuff that they're going to make you do next, which is annoying. All right, so 20 and 86%, probably not too much difficulty with that for you guys. Okay, so then let's take a look at, we're actually going to skip number 6, 7, and 8, because I think those you can do on your own. Let's take a look at 9, 10, and 11. So they want to know what percent are not shaded, what percent are shaded dark, and what percent are shaded light. So number 9 is not. Number 10 is going to be dark, and number 11 is light. Okay. All right. So this one is kind of hard to tell. Fortunately, on your paper, you can just make little dots in the ones that you've counted. It's almost easier just to count them for especially for the light shaded ones. Just because it goes around in a square. But really what it is it goes 10 across one way, and then parallel to that, so on the bottom, so if we did the top straight across, the light shaded one, so I'm looking at number 11 actually first. I would suggest for this one, just because it's so weird, do the not shaded, just calculate it. Figure out how many are dark, how many are light, add those two together, and then subtract that number from 100 to figure out how many are not shaded at all. Otherwise, you're counting and it's going all over the place. So actually, you know what? Let's start at number 10. Dark shaded. Okay, so the dark shaded ones are the little boxes. There's 5 of them. Each box has 4. So we can just go 4 times 5 equals 20. This is going to be 20%. Okay, so 20% of them are shaded dark. Now we've got to count the light shaded ones going around. So really what you have is you have 10 across on the top, 10 across on the bottom, okay? Those stay the same. But then, when you do columns, you can't do 10, right? Because the top one and the bottom one have already been counted. So you don't want to do 10 on the sides. Instead, it's going to be 8 on each side. So 10 plus 10 plus 8 plus 8 is 36%. Not quite sure if hopefully that made sense. Really what it is, it's like this. All right, so if we say that this is 10, we can't do that because we've already used this, right? We've already counted this part. So now we have to go, we could do it from there, but it's easier just to say, okay, this is also 10, and now we've counted this. All right, so you have one on the bottom taken off, one on the top taken off. That means that there's 8 right here, and there's 8 right here. Okay, hopefully that maybe makes a little more sense. 10 plus 10 plus 8 plus 8. 8 plus 8 is 16. 10 plus 10 is 20. 20 plus 16 is 36. All right, so that's that. Now we can just add 20 plus 36 is going to equal 56. Okay, and then you can just subtract 100 from 56, or 56 from 100, sorry, 56 from 100 to figure out what's left over, because whatever's left over is going to be the not shaded part. Well, I can just tell you right now it's 44. Okay, so this is 44% for number 9. Number 10 is 20%, and number 11 is 36%. Okay, let's see, that's easy. I apologize for numbers 1, 2, and 3 on the quote-unquote homework, which all of this is homework because you're at home. They're a little bit obnoxious, but it is what it is. I guess it's just 2 and 3 because number 1's done for you. Really, you just kind of almost have to count it up and then kind of do the same thing that I did here. They give you the dark shading, just figure out what the light shading is and subtract that from subtract the 2 that they give you, which they give you this one, and then you figure out that one, add those 2 together, subtract it to find the non-shaded, which is going to be the most of it. All right, those are all pretty easy. Okay, let's talk about turning from decimals to percents. Again, this is actually super easy. It's mostly just a matter of wrapping your head around it. So when you were looking at those squares that had 100 things in them, right? And if you had, say, like 76, I don't know why I wrote a 5. 76 squares out of 100, right? And we said that that was 76%. Okay, just like that. Yeah? Everybody's on board. Sorry about the terrible writing and the fact that I said one number and then started to write another one. All right, so 76 squares out of 100 is 76%. Everybody agrees, right? What if I said that we were talking about decimals, okay? And that 100 was equal to 1. Well, if that was the case, then 76 out of the 100 squares would equal 0.76, right? Because the 100 equals 1 whole. All right, 0.76. Now, and when we start talking about converting between fractions and percents, you'll see this kind of come into play a little bit more, but they want to start you off with decimals because it's easy. Notice, right, I had 76%, and then I literally just moved that decimal 2 spots over, and that was all it took, okay? When you are converting between decimals and percent, you just have to move the decimal 2 spots to the left if you're going from a percent to a decimal, okay? If you're going from a decimal to a percent, you move it 2 spots to the right. So let's take a look here at some of these problems. I'm not going to worry about the shading thing, again, because you guys already understand that. Okay, so let's look at, we're going to look at number 2, and we're going to look at number 4. All right, so this is number 2, is 47. I don't know why they wrote out the word percent, but this is the symbol for percent, and that's what's going to be used forever. Sometimes people like me are lazy and they don't quite pick up their finger, and so you end up with kind of a little circle that's attached to the line that comes down, and sometimes it almost looks like a Z with 2 circles at the end. It means the same thing, it just depends on how lazy the writer is, and I tend to be lazy. So when I'm doing percentage, if I'm not being very careful like I was writing that, it usually looks like that, okay? Still means percent, it's just laziness. So try and not have those if you can, but if you have them, so be it, all right? So 47%, you don't have to write out the word. Now, like I said, if we're converting from percent to a decimal, right, we're just moving that decimal point, which is technically right there, and we're just moving it over 2 spots, right? So it becomes 0.47. Those of you who are really into baseball are probably familiar with seeing things like that. If you have a batter who's batting, I don't know, if you look up a batter's percentage, it's usually written as something like 218, something like that, right? That's how they would write a batter's quote-unquote percentage. It's not written as a percentage. But what this means is that when he hits, or he gets a hit 21.8% of the time, see, there's lazy again. So those of you who are maybe more baseball nerds might be a little more familiar with the conversion than other people. But all you do is you're just going to move that decimal over 2 spots. Okay. So then number 4. Let's not do 4. Let's do. Oh, I tell you what. Let's do number 10 and number 11. Okay. So this one pretty easy, right? Now 10 and 11 involve converting a decimal to a percent. So number 10 is we are converting 0.06, and then number 11 is 0.6. Okay. So So again, all you're doing is you're moving this decimal, okay? Now, unlike when we were converting from percent to decimal, we're not moving it to the left, we're moving it to the right. So we're going boom, boom, decimal goes there. So that is equal to 6%, okay? And it's, I could have written 0.6%, but you know, when you're writing, if I asked you to write the number 5, you wouldn't write 0.5, right? You would just write 5. Same thing here. Yes, technically there's a 0 there, but we just drop it because it doesn't matter. Okay, now here, we're moving it. We go there, and well, we've run out of things to go around. But just like we talked about way back when we did decimals and you multiply them times like 10 or times 100, even if there's nothing there, there is a 0 there, right? So you move it, so this becomes 60%. Okay, always move it 2 spots when you're dealing with decimals converted to percents. And when you're dealing with percents converted to decimals, you move it 2 spots the other direction. All right, hopefully that makes sense, and that should get you through most of this stuff. Let's take a look. One more, just, let's see. So this is going to be number 16, okay? Now it's asking you to convert from percent to decimals, and it gives you 4%. All right, so 4% converted to a decimal. Well, once again, we're going to move it 2 spots, right? So our decimal is sort of right there. Moving it 1, 2, but now we have to write something in. So it's going to be 0.04 is how you would write it as a decimal, just like that. All right, that should get you through all of lesson 5. Now, lesson 6 involves converting between fractions and percents. So, really, when you're converting between a fraction and a percent, for the most part, they are going to give you numbers that multiply really pretty to equal 100. If you can get 100 as your denominator, then it's easy, okay? Or even if you can get 10 as your denominator, you know, just multiply times 100, and then, or times 10 more, and then that gets you to your percentage. So yeah, so if you remember from, I think it was the last video anyway, where I was talking about converting to compare decimals and fractions, right? You had to divide the numerator, the top number, by the denominator on bottom. So 2/3 would be 2 divided by 3. That's one way of doing it. However, if you can just find a equivalent fraction that is also that has 100 or has 10 as the denominator, then there's a lot less work involved. You don't have to do that division thing. So if we were going to convert 2/3, which I don't think they give you anything. Okay, good. Everything they give you is nice and pretty. So if you were to convert like 2/3 into a percentage, right? 2 divided by 3 gives you 0.666666 for eternity. So you would just write like 66. Well, maybe you'd write 67% if you wanted to be real cautious about it, or you'd write 66.66%, something like that. But these are all going to be much prettier and much simpler. All right, so let's take a look at, and we'll just look at number 1, just because it's there. All right, so they're going to give you 7/20ths written as a percent. And they actually show you, hey, you're going to multiply the top and the bottom times some number, right? And put little question marks like that, so that it is over 100, okay? Well, we know that 20 times 5 equals 100. And whatever we do to the bottom, we have to do to the top. So we're going to go 7 times 5. 7 times 5 is 35. So that means that this is equal to 35%. All right, 35 out of 100 is the same as 35%. It's also the same as 0.35, but again, if we did that, then we would just move the decimal over 2 spots, and then it would be 35%. Let's see, let's do Okay, so do notice on where you're converting between percentage and fractions that it asks for a simplified fraction. That means you have to find simplest form. So let's take a look real quick at number 6. Okay, so 6 gives you 80%, and they want you to write that as a fraction. Well, 80% is 80 out of 100, so we can start there. Okay? But that's not simplified, right? Well, for one thing, 80 and 100 are both divisible by 10, so this could be 8 out of 10. But that's not simplified, right? Because both 10 and 8 are even numbers, and they can both be divided by 2. So that means 8 divided by 2 divided by 2 is going to be 4 over 5. Now, there's no number that goes into both 4 and 5 and gives us a whole number as an answer because 5 is a prime number, so there's our answer, so 4/5. Okay? So it might be tempting to start here at this 80% and just go, oh, 80 out of 100, done. But that's not a simplified fraction. That's not what they're asking for. You could even have looked at this and said, oh, well, 80%, I know that's going to be 0.80, which is 8 over 10. It's 8/10. So I'll just write 8 over 10. But no, that's not a simplified fraction. You got to go all the way to 4/5. You can do it. It's not too hard. Let's see. Any other ones that are tricky? We'll do number 11 just real fast. It's not tricky, but just so you see another one of them. All right, so number 11 is 3/5 as a percent. Okay? So kind of like number 1, this is going to involve putting it over 100 to figure out what the percentage is. Okay, so 3/5, really what you want to get to is over 100. All right, so what do we multiply 5 times to get to 100? Well, 5 times 20 equals 100. And so we can just go 3 times 20. 3 times 20 is 60. Okay. So that means that this, as a percentage, is 60%. Cool? Cool. All right. So that looks like it. I don't think any of the rest of these are too difficult. You'll probably be okay. And if nothing else, that gets you to the first mid-chapter, I guess, sort of, checkpoint. So there's a checkpoint here, then there's a test after you get done with, I think it's lesson 10. Then there's another checkpoint in between 11 and 20, and then a test at the end, of course. So there's that. Hopefully this made sense. Again, as always, if it didn't, feel free to join me on a Google Meet, or you can always just make a Google Doc and share it with me that just says, hey, I've got a question about blah, or you can just have your parents email me, or if you have an email address that's not a school account because that's not an email address, you could always email me with your questions. That's totally fine. I'm always happy to do anything I can. I hope you guys are having a great day, and I will talk to you later.